So my name is Dan Reynolds, and for the past 3 months I've been building autonomous mobile robotics for my graduate studies at the University of Maryland. And the end result has been this guy. Now this is a robot that runs on a Raspberry Pi on the top there, made of a sheet metal chassis. It has 4 different motors and gearboxes and wheels. It's got 2 encoders, one on this wheel and one on this one. It operates a gripper with a servo motor. It consists of 3 ultrasonic sensors along the top, an IMU in the back here, as well as a Pi camera on the front. The vehicle uses all of these different sensors and things to complete the grand challenge, which was to mimic a autonomous robot that might have the task of delivering COVID vaccines from the cold storage unit to the injection site. Now this requires a ton of different things that the vehicle must do, which including, reading QR codes to know the correct file to be triggered by an email, to find its way in an unknown environment, as well as to use facial recognition to know that a personnel is there and ready to take the shot. But before we get into all that, let's take a look at how it was built. With the vehicle now built and able to be teleoperated, we needed to implement all the features that will make it ultimately autonomous. Now this includes color segmentation, tracking objects, driving in a straight line, making sure the vehicle drives in the path that we want it to, as well as implementing the path planning, which was a wall follower. So you'll see some of the clips of the test calibration up ahead, all the things I just mentioned and more. Let's take a look. So that should give an idea of kind of some of the work that went into just constructing it, as well as testing it, calibrating it, and getting the vehicle to ultimately run right in the Grand Challenge. Now, the vehicle was able to successfully complete all of its objectives as it was going through it, and I'll explain the Grand Challenge as we watch the video of the vehicle performing it. So, without further ado, here is the video of the Grand Challenge. For the video, I'm going to give a brief overview, and then in the following ones I'll go over the details. So it first gets initiated by receiving an email. It then reads a QR code which tells it which color vial to go get. It then leaves the cold storage area, calibrates itself so it's parallel to the wall, and heads in a straight line to the corner. At this point it reads a QR code again that tells it to localize. It then drives straight ahead until it reaches the injection site, at which point it will be cued by a facial recognition that a personnel is present, and it'll drop off the vial. It then leaves the injection site, recalibrates towards the wall, and heads towards the arrows, which is the next form of localization. If an arrow is present that tells it to go left, it localizes. It then heads that direction, avoids the box, and then heads back to the cold storage where it will await its next QR code to tell it the next color. So each of the QR codes tells it a specific vial to get. The vehicle then goes to get the vial by using a technique called color segmentation, in which case it takes the image from the PI camera, and any pixels that are within the color of a bounds of color are treated as a positive, and anything outside is a negative. The contour with the biggest positive cluster is likely the object we want to get. We can then draw a bounding box around the circle and track the center of that object and make sure it aligns with the center of the gripper. It then drives forward and grabs the object. The way it navigates through the course is a wall following algorithm, in which if the vehicle has no wall to the right, it will automatically turn right. If there's a wall to the right and a wall in front of itself, it will turn to the left. If there's a wall to the right and nothing in front of it, it will continue straight forward. The key thing to this is that it allows you to continue to follow the wall at all times. I was having issues with drift going to and from the wall, which is why I added the second sensor so I could ensure that I was parallel to the wall. This also helped correct for IMU drifting over time. It also allowed me to say that if I was slowly going away from the wall or towards the wall, I was drifting, and I could correct it. You'll notice right now, as it's avoiding me, that it does that little wiggle thing. The reason for that is because when it was turning right, it was detecting my genes, so it was ready to turn right, but then when it was facing forward, it could see me, so it was doing this little wiggle thing until it got close enough to the wall to proceed. The QR codes in the corner, this is also what helps with having the ultrasonics on both sides. Since I localize in the corners, I can get the exact XY position of my vehicle by reading the distance to the wall in front and to the right of me, rather than having localization in only one direction. So this is pretty much, it's completed all of its tasks. The localization with the arrows works the same way. It just uses color segmentation as well.
So as can be seen in the video, this little guy here was able to complete its task. It delivered all 3 vials to the injection site in the correct order. And here is exactly what the trajectory of the robot through the Grand Challenge looked like. And it was able to do this in an unknown environment. Should the obstacles change, the vehicle would still be able to get and deliver its vials from A to B. Should the order of the vials change, it would still be able to do it. That is the key thing that makes it autonomous. None of this stuff was predefined. It did it on its own. So I hope you enjoyed the video, learned a little something, and thanks for watching.